And talk about voltage dividers and how they're needed and why they're needed to protect your Arduino. Go over a little bit about what is a voltage divider and using a voltage divider to monitor system voltages, and what kind of analog input protection we will need. Now, what is a voltage divider? As you remember from previous modules, your Arduino has a limit of 0 to 5 volts for sensor voltages. And there are many sensors that exceed that upper limit. For instance, your power supply monitoring, 0 to 15 volts. If you've got a 12 volt supply and you want to monitor that with the Arduino, set your upper limit to 15 volts so that you have a little bit of range for higher voltages. There are a lot of sensors out there that are 0 to 10 volt outputs. So somehow we have to come up with a way to scale these voltages externally to the Arduinos so that the Arduino never sees more than 5 volts. And a voltage divider provides a way to scale your input voltages to levels that are safe for the Arduino. It can be built very simply with 2 resistors, and the voltage that you're monitoring is then divided in proportion to the values of the resistors used in the voltage divider circuit. Here's a simple voltage divider. We have R1 and R2, 10K and 10K, and this works out to be a divide by 2. So whatever voltage is at TP1, half of that voltage will appear at the Arduino pin A0. So if we were to apply 5 volts at TP1, the Arduino would see 2.5 volts. If we applied 10 volts to TP1, the Arduino would see 5 volts. So as you can see, this voltage divider would work with the Arduino for any signal up to 10 volts. Now looking at this with details, we have R1 and R2 forming the voltage divider, and the input voltage is connected to the point TP1. And the connection point right here between R1 and R2 is the output of the voltage divider and connected to the Arduino. The bottom side of R2 must be connected to ground. You'll see later on what happens if that floats and is not connected to ground. If it becomes disconnected from ground, you have the potential of burning up or frying your Arduino. Here's the formula, and we're going to use the voltage at TP1 here as Vin and the voltage at A0 as Vout, and Vout will be Vin times R2 divided by R1 plus R2. It's very simple. And if we look at this case, we insert 10K into both of those, you'll see that Vin is equal to 10K over 20K, which is a 0.5 volt ratio. So Vout will be equal half of your Vin. Now we can use these voltage dividers to monitor system voltages or various things throughout your ROV, and the most likely thing to monitor is a tether voltage down at the ROV. If you were to install an Arduino inside the ROV, you can monitor what your tether voltage is down there, and you can monitor exactly what your ROV is receiving after the voltage drop in the tether. And this can help you determine if the tether is over or undersized. Now, in the previous example with the R2 is equal to 10K, you saw that the limit was 10 volts. Now if we change R2 to 5K ohms, that changes our ratios around a bit, and you can see that we now have a 15 volt headroom that we can measure. So we can measure any voltage up to 15 volts with this 10K, 5K, R1, R2 ratio. Over here on the left you'll see a little table. If you apply the 15 volts Vin, the Arduino will see 5 volts. If we apply 10 volts, the Arduino will see 3.3 volts. If we apply 5 volts, the Arduino will see 0.67 volts. So now the Arduino will see these voltages that are scaled by the external divider. When we go and do our programming, we're going to need to multiply our sample values by the reciprocal of our external divider. Now we scaled to 15 volts, not 12 volts, to allow for variance in input voltage sources. If you connect up to a power supply, it may be 13.8 volts. A fully charged battery might be 14.2 volts. And you want to make sure that whatever you connect up to the Arduino will not exceed 15 volts. If you feel it will exceed 15 volts, you'll need to scale the divider accordingly. Okay, now we're going to talk about analog input protection on the next video, and this is how you can protect your inputs if we do exceed, for instance, the 15 volts or go negative voltages.